Welcome to the part 4 of the Runtime Fabric series. I hope until now you would have been enjoying this series. In this video, we will understand the DNS concepts within the RTF cluster. So let's get started. So here is a current infrastructure setup for RTF. We created a VPC, then spun up an EC2 instance that's being used as a controller node, followed by two more EC2 instances that behave as worker nodes. Since we have used the appliance model, a planet container was created that spans across all the three nodes. And on top of this container, we have Kubernetes and its supporting services deployed. Now assume we deploy two pods on the Kubernetes cluster. These pods would be deployed on the worker nodes. Now how do these pods communicate with each other? Of course, they can use clusterIP services IP address and call each other. But using IP address of the service is not a good approach. We want an easy to remember domain name and use that instead. So one option to do so is to use the ingress and get a domain associated with the ingress. Now when we call that domain, it resolves to an IP address of the ingress. Now it will be the ingress job to route the traffic to correct pod based on its cluster IP. This approach looks fine, but it's not efficient as you end up increasing the network hops. Now, how do these network hops increase? When you use a custom domain that is pointing to the ingress controller, you'll end up reaching out to the DNS server, which sits outside the Kubernetes cluster. Which means that to resolve the domain, you move out of the pod network. Then once you get the ingress IP address, which is outside the pod network, you end up taking one more hop outside the pod network to reach the ingress. Finally, the ingress would route the traffic to pod B. So there are unnecessary hops in between, which I could have avoided by directly reaching to pod B by using some domain internal to the Kubernetes cluster. One more line of reasoning that might come to your mind is why not associate a domain to the cluster IP of each pod and update the DNS outside the Kubernetes cluster with the A records of those domains. Now, even if this approach is possible, it doesn't make sense to move out of the cluster just to reach the DNS and get the IP address of nodes that sit inside the cluster. Also, the main job of the external DNS is to have A records of the domains that are associated with nodes and not with pods. So to solve this problem, we need a DNS internal to the Kubernetes cluster. When using RTF appliance, you would have three types of DNS. One is for the planet container, one is for the controller nodes, and one for worker. Now each controller will have its own DNS and the same applies for worker. As you see in the diagram, worker A and worker B have their own DNS. Same is true for controllers as well. If there are multiple controllers, they have their own DNS. In this case, we just have one controller, so there is only one DNS for the controller. Let's talk about the core DNS service that's on the planet container. Now this is a service which is exclusive to a planet container for its working. This isn't used by a mule application pods deployed to Kubernetes cluster. This service also plays an important role in maintaining the leader node among all the other controller nodes. In case if you're using BYOK flavor of RTF, you won't have the planet container, hence no core DNS service. Now let's move on to the Kubernetes cluster. Inside the Kubernetes cluster, each node will have its own DNS as seen in the diagram, which are in the form of pods. Now, any pod that wants to resolve the domain for any other pod in the cluster, it can reach out to its respective DNS. Now that we have the core DNS pods specific to the Kubernetes cluster, let's see how the flow looks like. We have the same scenario. Pod A wants to communicate with pod B. When we deploy a mule app, RTF automatically assigns a cluster IP service to the application. so that we get a static private IP for the pod. This service also helps in getting a fully qualified domain name in the following format: namespace.podname.svc.cluster.local. In case of mule apps, the namespace can be replaced by the ID of the environment in which the app is deployed. Now this domain will have an A record in the core DNS pod, and it will be updated across all the DNS pods in the Kubernetes cluster, including the core DNS service which is in the Planet container. So if pod A tries to communicate with pod B using the fully qualified domain name in the format we just discussed, then core DNS pod will return the cluster IP for pod B, and it can be reached directly without leaving the pod network. That's how it resolves the problem of unnecessary hops that occur while going through the ingress. Now, what about accessing the server on the internet using their fully qualified domain name? The core DNS will only have A or AAAA records for the pods in the cluster. For any FQDN or fully qualified domain name outside the pod network, the DNS query would be automatically forwarded to the node on which the pod resides. And eventually the DNS configured on the node gets the request. So in this diagram, a request for google.com's IP address comes to the core DNS pod of the worker B. Since there are no entries for google.com, it moves to the node and gets redirected to the DNS used by node named worker B. And eventually, from the DNS node, it gets the IP address of google.com. You should always use the svc.cluster.local domain if trying to access the mule applications within the Kubernetes cluster. But now the question would arise, should we not at all use the ingress for pod-to-pod communication within the cluster? Well, in some cases, you can use ingress for internal communication. For example, ingress allows setting up TLS at its end. When it receives a request, it terminates the TLS and routes the request to the respective pods. Since TLS is already established and also terminated at the ingress to pod communication can be done without TLS to save resources. So in such cases, we decide to have mule applications to use HTTP listener instead of the HTTPS listener, because the TLS is handled at the ingress level. Now, if there arises a situation where you want to use two-way SSL in your Mule app to communicate with other Mule apps, in such cases, you cannot directly call other Mule app using their svc.cluster.local URL because they have the HTTP listener now. So you'll have to go through the ingress only. Now, this is hypothetical example, but I hope you get the crux. Another example could be load balancing. The cluster IP service can do load balancing in case of multiple replicas of the pod, but by default it's round robin. In certain cases, you might want to leverage the load balancing capability of the ingress controller. So in such scenarios, you can still use the ingress to reach other pods. So ingress is still relevant for internal communications. Now it's time for some hands-on. I've logged into the controller node and let's execute a few commands. First, we will validate that what we understood about the core DNS service, which resides on Planet container, if it is what we saw in the slides or not. So I've logged in as a root user. Now I'll have to enter gravity. So let me type gravity, enter. Now always remember, gravity has a Planet container, and that container is only available in case of appliance flavor of RTF. If it is BYOK, you won't have gravity at all. Alright, so now we need to check the DNS service. So to check that, I can use systemctl status core DNS. So it shows that this service is active and running. Alright, so this proves that there is a service named as core-dns, which is on the Planet container, and the process ID is 73. All right. Now let's check the configuration file. Let's come out of this. Let's clear up. All right. Now I'll open cat etc core-dns core-dns.conf. So this file is basically a configuration on how to retrieve the values from the DNS. So the bind specifies that this is the IP address wherein the DNS is present, and then if in case if the entries are not found, it forwards to this particular IP. So this is the IP for the of the DNS server, which is on the VPC that we have created. Apart from this, I also said that the core DNS service maintains the leader node among the controller, right? This is done by a Planet agent which maintains this. So how do we find that out? So there's a file. Let's enter that file, etc core-dns.host. So this file has those details. I'll hit enter, and if you see, I can see the private IP of the controller node. Right now in my case, I only have one controller node, so that is the leader. If there are multiple controller node, the leader's IP address, private IP address, can be seen here. Now let's move on to the DNS that's part of the Kubernetes cluster. So we have seen that the controller has its own DNS and the workers have their own DNS. So let's get the list of pods. Let's use kubectl get pods -n kube-system, and let's use the flag o wide. So we see that we have 3 DNS pods for each of the node. So this is the core DNS without any suffix except this hash is that of the controller, whereas the one that ends with worker is of the worker. It's visible from the node IP 44. The one that we are logged in is the controller, whereas 111 and 203 are the workers. Now, one important point is that I am logged into Gravity and then I'm executing these commands. But even if you're not inside of Gravity, you can still run this command and get the list of pods. The only thing that won't work if you is that if you are on BYOK flavor of RTF, you won't have the Planet container, which means you won't have that core DNS service, which is part of the Planet container. This DNS service will always be there. So what I'll do, let me just exit the Planet container, assuming that we are on uh, BYOK also. So this command should be executable outside the gravity, outside the Planet container as well. So kubectl get pods -n kube-system. So it's the namespace -o wide. So I'm able to access, nothing changes, everything remains the same. All right. So these are the pods which are behaving as DNS. Now these pods are also fronted by services, right? So let's list those services. kubectl get svc -n, namespace is kube-system, and let's use the white flag. All right. So we can see cube DNS. Now we only see 2 services, so that's fine because as compared to pod, we don't need to have multiple services, right? These are workers, basically these are replicas. So a service can span across multiple replicas. So that is why for worker, we have only one kube DNS worker service. And also for controller, you'll always have one kube DNS service, irrespective of the number of controller nodes or pods you have in place. Now here, if you observe, you can see port 53 is open and the protocol it's using UDP. 53 also accepts TCP, 9153 that accepts TCP. Same is the case for worker. Now let's see the config map, which has the details about this service. So it will have basically detail if it doesn't find any of the entries where to route the traffic, the way that we saw in the core DNS service, which is part of Planet container. So let's check that out. So so it will be in a config map, and the name of that config map will be core DNS. So both of the services are created out of a config map, and its name is core DNS. So let me run the command kubectl get cm stands for config map, namespace is kube-system, and the name of the config map is core DNS. Export OYAML. Let me export this, and it's exported. It's not indented correctly, so what I can do is let's apply some formatting. So let's new line. Okay, so this should do the job. I think there's some mistake in the formatting. Let me fix this. So it has to be SED as the prefix and should work now. Yeah, so I now have the YAML file, the content which was inside this core file, right? It was string JSON. So it's just that now it has evaluated as a proper JSON, or it has indented correctly based on the new line character. So right here we see the port 53. We do not see IP address because it's not final yet. So it's dot. It's a service, right? So when it deploys, it gets an IP address. So it's 53. Then all the details. Then in case if it's not found, right? So what it does, it forwards to this IP address. If the A record or AAA record is not found, it will forward to this. And we saw this, it was the same as that in the core DNS service, which is part of the Planet. So this is basically a server present in my VPC that we created, and it can serve the DNS request from there. So if it doesn't find in the DNS that we have for kube-system, it eventually contacts the DNS which is present in the VPC. So this is the server. This is the node which is in the VPC, and it's basically not part of a Kubernetes cluster. All right, so that's about this config map. Now, what we can do is let's try to log in into a pod and see what DNS it uses. Here it looks fine that this is the service, these are the no, pods created, but does it actually use them? Let's try to find that out. So for that, the idea is to log into one of the pods. So we'll select a pod from the RTF namespace, and inside that we'll explore the DNS configuration file. All right. So for that to happen, let me get a list of pods in the RTF namespace. You can log into any pod which you feel comfortable. I'll choose someone in the RTF namespace. Get pods -n RTF. Okay, there's a typo. kubectl get pods and RTF. Okay, so I'll use this pod and let me enter this pod. So to enter this, you have to give the command kubectl exec. IT means interactive terminal. Pod name. Let's give the pod name. Namespace is RTF, and let me get a shell terminal bash bin bash. Let's hit enter. Again a typo. I think I should get a shorthand for this. kubectl command should work now. Okay, it should be exec, not T. I think I'm messing around with the. Okay, I found out the right command. So there was a space missing, and that is why it was failing. Now I think it should work. There is a command. Let's hit enter. So I have entered the pod. If you see, uh, it's complaining that I haven't specified the name of the container to enter. So by default, it's defaulting to a container named as Nginx. All right, now that I am inside the container, you can see root at resource cache. This is the pod, right? So I have logged in. So let's list what files do we have. Now let's enter the opt folder. Are there not any files? Okay, it should be the etc folder. So let me move a step ahead, cd etc. Let's see if there are files. Yes, we have files. And the file that we are interested is related to DNS. So let's search for that file. I'll do cat and it should be resolver, right? So it's there, resolve.conf. So if I hit enter, I can see the name server which is set to 10, 100, 253, 93, right? Now let's scroll up and check the services. So here are the pods and here are the services, right? Okay. So in this service, if I see this is the IP that's present in the pod, correct? And that pod resides on the controller node, the resource cache pod, right? And since it's residing on the controller, it's obvious that it will use the kube-DNS. So this proves that all the pods which are on any container, any node, right? If it is on a controller node, it will use kube-DNS. If it happens to be on worker node, it will use this service, right? So it uses service and service in turn use the pod. Okay. Right now, I don't have any pod deployed on worker. The reason is that I haven't deployed any mule application. All the default pods that are created by RTF on its own during the installation gets deployed to the controller nodes. But the pods or the app, when we deploy our mule application, all of them would be deployed to the worker node, and then we would be able to see that they are leveraging the kube DNS worker. Since we are already inside a pod, let's try to access the different services, or let's try to check the resolution that the DNS provides for different fully qualified domain names. So to do that, we can use a command called as dig, but let's see if we have dig access inside the pod or not. So if I type dig command is not found, so we cannot resolve it. Basically, the dig command would give us the IP address for a particular fully qualified domain name along with the domain name server. But right now inside the pod, we do not have access to dig. So alternatively, what we can do is just to test the connectivity, we can use a curl command, which we definitely will have an access, curl lvk. And then if you remember in the slides, we have discussed how the fully qualified domain name is created. However, there's a correction to be made in that slide. The name should be, for example, if I want to access the log collector pod, right? So it has a service cluster IP. So it should be always pod name, then the namespace, then svc.cluster.local. In the slides, it's mentioned as namespace dot pod name dot svc.cluster.local, which is incorrect. So let's do this. So let me give the pod name, which is log collector. Then namespace is kube-system dot svc dot cluster dot local. Let's hit enter. And if I hit enter, it's correctly pointing to the right address, right? It's 10, 100, 72, 92. So it's trying to hit that. But since the port 80 is not open, it's getting stuck, and if after a couple of seconds, it will time out. The ports that we have, it's only 8083. So this means that it was able to successfully get the IP address from the kube DNS. And in this case, the kube DNS will be the one that is on the controller node because this pod is sitting on the controller node. Now let's validate one more thing. We'll try to use the same curl command or dig command from the planet container, because what we have understood so far that the planet container will have all the DNS entry which are present in kube DNS or the kube DNS worker together. But kube DNS and kube DNS worker won't have the entries in the planet container. So let's check if we are able to hit or do the curl command from planet container or not. So let me just come out of this pod. I'm out of this pod. Now what I can do is I'll try to enter gravity. So gravity enter. Now I'm inside gravity. Here I have access to the dig command. So I'll use dig. And then this is the FQDN that I need to get the IP address for. Right click. I'm getting values. Right. So question is this is a question section. I requested for an A record. In the answer section, I am getting the value which is 10, 172, which is the same as we have seen in kube-system get SVC. Okay, it also says about the server, and we have seen this server. It's 127.0.0.2. We have seen this previously, and it's on port number 53. So we are able to access from the gravity, which is the planet container. Okay, now let's go back to the node. Let's move out of this planet container. Now I'm inside the node. Now let's see if I'm able to access it through the node or not. So I'll copy this. Now inside the node, I do not have dig, so I'll just rather do a curl command. If it succeeds, then basically it gets the IP address. So let me do this. So what it says is could not resolve host. Now why do you think this has happened? So if you are thinking that the node is not part of the cluster and hence it doesn't have access to the DNS, which is the kube DNS worker and kube DNS. Also, it doesn't have access to the core DNS service. Then you're thinking in the right direction. That's the exact reason, because node is not part of the cluster. But the cluster is part of this planet container. If you remember the diagram, the very first thing that happens is on the nodes, all the three nodes, the planet container is created. And inside that planet container, the Kubernetes cluster is created. And that is the reason we were able to access the IP addresses or do curl command from the planet container to the nodes which are in the to the pods which are in the Kubernetes cluster. We can also do a curl command and dig from the pods which are in Kubernetes cluster. That's quite obvious. But we can also do from the planet container. But from where we cannot do is from the nodes, because node is not part of the pod network, right? There is an overlay network that has been created, and this node doesn't form a part of that network. That is the reason it says could not resolve host, because for this the IP, the DNS is different. It's 10.0.0.2 that we have seen previously, right? And the 10.0.0.2 is doesn't have all of this. But yeah, that 10.0.0.2 can be accessed by the uh, pods in this cluster, because in case if they do not find the entry in this kube DNS, right, it eventually reaches out to the 10.0.0.2 DNS, which is present for the nodes. Now let's also try to access couple of more services. So what I'll do is let's do gravity enter. Let's list out all the services. So kubectl get svc -n. Let me get all namespaces. Okay. should it work? All name spaces. Oh, what? Okay, so it works. So we see all the namespaces, and let's try to access which one? Let's take this net health. It's with this same thing. Let's do a dig on net health dot, which is the monitoring, right? It's part of monitoring. So monitoring dot svc dot cluster dot local. So the IP address that we get is exactly the same. It's 168. Now, when I do a dig in the planet container, remember it's via the core DNS server, which is this. I can optionally enter any of this node. Sorry, these are the service. I can optionally enter the pods, and I can also run the dig command. But unfortunately, we don't have dig. So what we do is we do a curl, because curl eventually calls the DNS and gets the IP. So if we get the IP, it means that it works there, right? So we are able to do this. We can also try a curl command on this. So let me do this, copy this, curl hyphen lvk. So this is a verbose log, and to skip any certificate validation. So otherwise it gives error. And what is the port that it's listening on? It's listening on 9801, right? So let me give 9801. Okay, so it's evaluating the correct IP address, but it's taking time to reply. Possibly it's not listening to the traffic on it, or let me try with HTTPS. No, it's not responding, but however, we see that it's trying to connect. So there's something. Let's try some other pods with the curl command. So let's try this influxdb curl hyphen lvk influx dot use this HTTPS namespace is monitoring svc dot cluster dot local, and the port number is 8083 or 8086. Let's try with 8083. Okay, it's refusing connection on 8083. Let me try with 8086. Yeah, so looks like it responded, but it said it's unknown protocol. So it's just to demonstrate that we can literally access the services by the curl command inside the Planet container. Now, what all services are there? You can just use the fully qualified domain name by following that convention, and can try to hit based on the ports that are seen here. Alternatively, you can also access the pods directly using the cluster IP, which is this directly. So it would prevent the trip to the DNS, right? And you can also use the pod IP address as well. kubectl get pods hyphen n hyphen all name spaces hyphen o wide. Okay, if I'm using all namespaces, I don't need this end flag. So I see this. So if you observe, the IP addresses of pods are different, right? So it's 10 to 4428. Uh, let's select one which is present in the service list. So the one that we have is resource cache. So let's see the resource cache. So it's having this 10 to 44, 84, 9, whereas service, right? 10, 100, 124, 249. So both the IPs are different. It's because this is a service that has been created on top of this pod. It's fronting that pod, because tomorrow, if this pod crashes, it will get a new IP. But the cluster IP service will always provide a static IP, which is this. So once the cluster IP is up, it provides a static IP plus it helps in getting a DNS entry with the convention that we just saw. So we can also do a curl command lvk directly on this, which is, what is the IP? It's 10, this IP, and what is the port that it's forwarding to? So it's 80 TCP, so it directly goes on port 80. Let's try to hit this. Okay, it's refusing connection on port 80. So there could be some other port, but right now we only see 80. So in this way, so this is just to give you an idea. Uh, let's try this capacitor. This one, this capacitor is, this is the IP, right? Let's see what port it's listening. To find out that port, you can see capacitor, it's having port 9092. So let's try this out. First, let's try to head directly with the IP address. So the IP address is this. This is a pod IP. Okay. So let's use curl hyphen lvk https. Let's remove this protocol altogether. So it's using port number 9092. Hmm. So this time around we get a proper response which is not found. So this service is at least listening on the port that we can see from the service. Now since we are able to call this, let's try with the service name for the FQDN. So the FQDN for this would be, let me change this. So then pod name is capacitor. Then the namespace is monitoring dot svc dot cluster dot local. Port number was 9092. We should end up with the same results, right? So we are getting not found. So this demonstrates the number of ways we can access the application, right? So we saw that we can directly use the pod IP addresses. We can also use a fully qualified domain name, which is of the format pod name dot namespace dot svc dot cluster dot local. Now these two methods are valid only if you are inside the Kubernetes cluster. Since I am inside the planet container and the Kubernetes cluster is made on top of the planet container, I was able to directly run those commands. But in case if you are having the BYOK flavor and you just log into the node of Kubernetes, you won't be able to do these things because you are outside the Kubernetes cluster. So either you need to get inside some pod and try, that's your only option, or else if you are on an appliance model, just enter Gravity and you have access to everything because everything is built on top of the planet container. This also validates our point that the core DNS service has all the DNS entries which are present in the kube system's core DNS pods, right? So that's all about the DNS in Runtime Fabric. I hope you would have found this video useful. Thanks for watching.